Since the dawn of civilization, we've looked up at the night sky and wondered, are we alone? It's a question that has haunted philosophers, inspired explorers, and driven scientists for centuries. But in the modern age, that question has evolved. It's no longer just about finding life, it's about finding intelligence. What if, out there among the billions of stars, some advanced civilization has already mastered the energy of its sun? What if their technology is so vast, so powerful, that it could be seen across the galaxy? Welcome to the search for alien megastructures, a hunt that pushes the limits of astronomy, technology, and imagination. The concept of alien megastructures didn't come from science fiction. It came from science itself. In 1960, a physicist named Freeman Dyson asked a simple question: what would a truly advanced civilization need? His answer was energy, more than any planet could ever provide. He imagined a civilization that had grown so powerful it could no longer rely on fossil fuels or even its own world's sunlight. Instead, it might build vast structures around its star to capture all of its energy output. This hypothetical structure became known as a Dyson sphere. It wouldn't be a solid shell, but rather a swarm of satellites or mirrors orbiting the star, each collecting and transmitting energy back to the civilization's home world. To us, it would look strange. The star would appear dimmer, its light flickering as the structures passed in front of it. But in the infrared, it would glow with waste heat, a telltale signature of an artificial design. That idea changed everything. It gave scientists a way to look for technology itself among the stars. To grasp the idea of a Dyson sphere, we have to think on a scale that defies imagination. Our sun produces about 400 trillion watts of energy every second. That's more energy than humanity has ever used, multiplied by 1 billion, again and again. A Type 2 civilization on the Kardashev scale, a hypothetical ranking of technological advancement, would harness all the energy of its star. A Type 3 civilization could control the power of an entire galaxy. For comparison, humanity today doesn't even reach Type 1. We're still limited to the energy available on our planet. But the thought that someone else, out there, might have crossed those thresholds is both thrilling and humbling. It means that if such a civilization exists, its presence might not be hidden in radio signals or spacecraft, but in the shadows of stars themselves. For decades, Dyson's idea was purely theoretical until something strange happened. In 2015, astronomers using NASA's Kepler Space Telescope noticed a star behaving in a way no one had ever seen before. It was called KIC 846-2852, or more famously, Tabby's star, after astronomer Tabitha Boyajian, who led its study. Kepler's data showed that the star's brightness was dipping dramatically, not by 1% or 2%, as with planets crossing in front, but by up to 20% and at irregular intervals. No planet could cause that. No orbit matched it. And the dips didn't follow any predictable pattern. For a moment, scientists and the public let their imaginations run wild. Could this be the first sign of an alien megastructure? Perhaps a swarm of massive panels orbiting the star, or even a half-completed Dyson sphere. The world's media erupted. Headlines screamed of alien superstructures detected. For the first time in modern history, the idea of a megastructure wasn't confined to science fiction. It was on the front page of reality. Of course, extraordinary claims demand extraordinary evidence. Scientists turned every telescope they had toward Tabby's star. They studied its light across all wavelengths: visible, infrared, ultraviolet, radio. If there was an alien megastructure, It would absorb visible light, but emit heat in the infrared. Yet the star showed no excess infrared radiation. That was a crucial clue. Whatever was blocking the light, it wasn't generating heat. Other explanations began to emerge. Perhaps a swarm of comets? Maybe clouds of dust from a disintegrating planet? Or fragments from a collision between moons or asteroids? Eventually, the data pointed toward a more natural answer. The star's strange flickering was likely caused by clouds of fine dust grains, tiny particles that scatter light unevenly and drift through space. The mystery was solved, or at least mostly. No megastructure, no alien engineers. But the hunt had begun in earnest. Despite the false alarm, the search for megastructures didn't end with Tabby's star. It evolved. Today, astronomers use the same telescopes and techniques that once hunted exoplanets to look for signs of alien technology. They study the light curves of stars for irregular dimming patterns, dips that don't match the clean, round silhouettes of planets. They search the skies for infrared excess, stars that shine too brightly in heat, as if surrounded by warm, artificial matter. And they listen for radio signals that might hint at energy transmissions or communication systems far beyond our own. Projects like SETI, the search for extraterrestrial intelligence, and the Breakthrough Listen initiative scan millions of stars, galaxies, and fast radio bursts for any sign that nature isn't the only architect in the cosmos. Even now, deep learning algorithms sift through data from space telescopes, trained to recognize the subtle fingerprints of technology, not just life. Because in a universe of trillions of stars, it's possible that someone, somewhere, has left a light on. The hunt for megastructures isn't just about finding aliens. It's about understanding our future. Dyson spheres, orbital swarms, stellar energy harvesters. These are ideas rooted in physics, not fantasy. If a civilization can survive long enough, its demand for energy will grow. Eventually, it will look to its star, the ultimate power source, just as we have begun to look to ours. In a way, searching for alien megastructures is like searching for a glimpse of what we might one day become. A mirror of possibility reflected back at us across thousands of light years. And if we never find one, if the stars remain empty, that too is a lesson. It tells us how rare intelligence might be or how fragile it is. The idea of megastructures forces us to stretch our imagination, but it also pushes the boundaries of science. Could a civilization really build a shell around a star? A solid Dyson sphere would be impossible. The gravity and radiation would tear it apart. But a Dyson swarm, millions of independent collectors orbiting in harmony, could be achievable, at least in theory. Such a structure could be constructed gradually, starting with satellites close to the star and expanding outward. Over time, it would dim the star's light and re-radiate that energy as heat, exactly the kind of signature astronomers are searching for. And beyond that, who knows what's possible? Maybe other civilizations have already built even larger wonders. Ring worlds, stellar engines, or galaxy-spanning networks. Perhaps they exist, invisible to us, cloaked in wavelengths we can't yet detect. Every discovery we make brings us closer to seeing more, to understanding the subtle patterns of the universe, and maybe, one day, finding that we are not alone. At its heart, the search for alien megastructures isn't about proof, it's about perspective. Every time we look for signs of technology among the stars, we're forced to confront our place in the cosmos. We realize how young our civilization is, how fragile our world remains, and how much room there is to grow. Whether or not we ever find a Dyson sphere or a shining alien beacon, The search itself unites us in curiosity. It reminds us that we're explorers, not just of planets, but of possibilities. And perhaps, one day, the faint flicker of a distant star will reveal something extraordinary, a pattern too perfect, too deliberate, to be natural. A whisper from across the galaxy saying, "We were here,